today we are going to discuss about parallel circuits. So here we can see there is a power supply which has 8 volts EMF, and we have an ammeter connected right next to it. Then you have two resistors, 20 ohms and 10 ohms, that are in parallel with it. There are voltmeters that are connected in parallel with those. Voltmeters are always connected in parallel. Also, you have two other ammeters, one on each branch, to measure the current in each branch. So what you're trying to find is the reading on each meter. Now, the first thing we need to know about a parallel circuit is the PD across each branch is the same as the EMF of the cell. To explain this in a very simple way, let me just do this one. So let's think about a normal battery, like a small, battery like that, positive, negative. So let's say this is an 8-volt battery. Now, if you connect a resistor here, obviously this 8 volts will be across this one. So if you do like more practical sort of a diagram, it makes more sense that way. Now, obviously, the PD across this is 8 volts. Now, if you look at the next branch, you can see you got another 10 ohm resistor that is also like that. Now, if you think about it, that is also connected across the same power supply. Like it feeds a full 8 volts. So that here is also 8 volts. So obviously the readings on each voltmeter, V1, V2, is also 8 volts. Now we know V1 and V2. Now, since I know the PD across this 20 ohm resistor, I know both resistance and PD, potential difference, so I can easily find the current in this branch. So how do you do that? Let's write V is equal to IR. Always write the formula, then substitute. So I know V is 8. I don't know the current in this branch, call it I, and R is 20 ohms. Oh, that's quite easy. All I need to do is divide both sides by 20. These two gets cancelled out. The current here is 8 over 20, which is 4 over 10, 0.4 amps. Now, I know the current in this branch here. Let's do it for here. Write the formula again. V is equal to IR. Let's write the values here. 8 is equal to I don't know. R is 10. Now, let's mark the current here. Current here is 0.8 amps. Now, the current here is 0.8 amps. This one is 0.8 amps. The reading on ammeter A2 is 0.4 amps. The reading on ammeter A3 is 0.8 amps. Now, we need to use these two to figure out the current in the branch above it. Now, if you think about it, the current that comes through this branch, the current that comes through this ammeter, through this branch, is the current that's split up as 0.4 and 0.8. So after split up, if it is 0.4 and 0.8, before the split up, it must be the sum of the two. So reading on ammeter A1 is 1.2 amps. Here's a question for you to try. So I'm going to do this question now. So like we figured out earlier, there's a 6 volt power supply. So I know the PD across this is 6 volts. Same thing for this one. And the same for the other one. Now, to find the current in each branch, I'm going to write V is equal to IR. So I can say V is 6. I don't know. R is 4. Divide both sides by 4. And you can see in the first one, across them out, the current here is 6 divided by 4 is 1.5 amps. Now, I can do the same thing for this one. And I do this exactly the same thing to this one. Now let's mark the current on each branch. So we know this is 0.5 amps. and we know this is 1 amp, and we know this is 1.5 amps. Now, if the current in this branch here is 1 amp, and the current in this branch here is 0.5 amps, obviously the current in the branch above it here must be the sum of 1 and 0.5. So that must be 1.5 amps. So you can see this one here is 1.5 amps, and this one here is also 1.5 amps. Obviously, the current in the branch above it here must be the sum of these two. So that will be 3 amps. So the reading of the ammeter here is 3 amps. That's the final answer to this question. Here's another question for you to try. So like the previous questions we saw, it's 21 volts. So each branch gets 21 volts. So the PD across each branch is 21 volts. And all we need to do is we need to write V is equal to IR for each one. So let's start with this one. V is equal to IR, and I is equal to V over R. And you can see that's 21 divided by 7, and it's 3 amps. So we know the current in this branch is 3 amps. For this one, I is equal to V over R, that is 7 amps. 3 here, 7 here, add them up, 10 amps. For this branch, I is equal to V is 21, R is 15. So this one here is 1.4 amps. The value of capital I is 10 at 1.4, 11.4 amps.